My name is Kehinde Adeleke. I work at Mastra, not Kepler. Forgot to update that. So I work on Mastra AI, and we build a framework, a TypeScript framework for AI agents. So Mastra is pretty cool. We are open source as well. So if you just go to mastra.ai, you can check that out. It's pretty cool. But then today is what the talk is going to be about, and that's Rust. I like Rust. I also like C. I realized I like C yesterday, which is very nice. So today we're going to be writing Rust. And I wanted to talk about Rust because Rust is quite popular on Twitter, right? It's the hype. But then I think Rust is pretty scary because it's pretty low level in a way. But then what I wanted to show was that, of course, like Rust is hard, but it's not the worst thing in the world to learn, right? Like if you build something and you read the book, the Rust book, you can pretty much learn Rust. So I have a very short slide. It's not a lot because we're doing like hands-on stuff today. So if you have your computer, then you're going to like enjoy this session. So I'm just going to go through the slides real quick. And yeah, like I said, Rust is fun, but it's also hard. The best way to get started is by building something easy peasy. And then, yeah, so if you scan this code, it takes you to like the starter repo I've set up. And I have like a boilerplate, which Claude or like ChatGPT can also do. So it's just like a boilerplate with the repo set up with cargo. And you can clone that. I'm going to leave this for the next like 10 seconds. Anybody else? Somebody else still scanning? All right, we're good. So we're going to cover a bunch of things in 1 hour. This is a lot to cover in 1 hour, but I'm going to try my best to just make this clear as possible. So we're going to talk about organizing code, vectors and strings, how to handle errors. I think error handling in Rust is pretty great compared to like JavaScript, where you can decide not to handle errors. And then talk about traits and lifetime. And then because this is a TDD approach, we're going to write tests, maybe one test or two tests. It depends. But we're going to have like a test, that test functionality, and we're going to see if it works or not. And then finally, the goal of this session is just to see that when you walk through a project in like a test-driven approach, it kind of gives you like a gentle introduction to the ecosystem. It shows you like the quirks of the language and also what you can do in the language. And then finally, this is something exciting. If you have an interest in Rust, it doesn't matter if you're proficient in Rust, you're a Rust station. So I got this from a talk I'm going to share after my session from Rust Nation UK. So yeah, let's get started. So the first thing I'm going to do is to clone the repo. So let me just grab that real quick. And yeah, so this is the repo called Grep. This is not very clear. Is this clear enough? It's clear enough. Okay. So I'm gonna just clone this real quick, and there's gonna be a lot of talking, but I think you can pause me and say, oh, okay, can you like repeat this a second time in case I'm not very clear about it. So yeah, we're just going to do that. This is kind of slow. Yeah, so I'm just gonna clone that real quick. Yep, and it's loading up. Oh yeah, exciting. So yeah, we have like a basic Rust file. I'm gonna zoom in, so this is clearer. And yeah, so this is gonna be a speed run, but as I speed run this, I'll try to explain some of the core Rust concepts and why Rust is seen as memory safe, because that's why you use Rust rather than C or C++ in a case. Right, so we have like a basic Rust file, and to run this file, I can just do cargo run, which like, builds an executable and then prints to the console, easy peasy. But then, what we're going to build today is something called a grep. Oh yeah, I forgot to talk about that. So does anybody know about grep, the CLI tool? Yeah. So grep is pretty cool. Say I have like a file. I want to look for like a pattern in a file. Grep helps me do that. So grep is just going to try to simulate that. And hi is Japanese for fast, so fast grep. So yeah, so what we're going to do is basically a bunch of stuff. We want to build a Rust program that can take two things. It takes in a query, which is a string, and it takes in the path to a file. And so we want to, scan the file, look for lines in the file that matches the query, and then print out to the standard output, as we see here. So yeah, the feedback is a little bit slow, but I think we can make do with that. So the first thing we're going to do is we're going to use a concept called like a struct in Rust to define a bunch of related concepts. So we know that we're going to scan the environment, get something from the environment. This is what I mean by environment. We're going to scan the terminal, and look for something we supply to the program, get what we scan, and then make sure that our Rust program has. Yeah, we don't have a lot of time. So yeah, so I want to just grab the query and the file path from the terminal, but I want to group them together into like a struct. Kind of like, it's like a type. A struct is basically a type in Rust. If you wanted to say, oh, what's something similar in TypeScript, it's just like defining an interface, but I think structs are more powerful than that. So we're going to have a struct called config, which is going to be the config we get from our terminal, and we want to take two things. The first thing we want to take is the query, which is a string, and the file path, which is also a string. I can't type today. Yes, so we have the struct, we need the query, we need the file path. That makes sense. But then the interesting thing about structs in Rust is you can implement methods or function on the struct by using a keyword called implement. So impl config, and then we can say on this struct we want a function, and we're going to call the function build. Build takes in our command line argument called args, which is a collection of items, so a collection of string in this case. And then because Rust is statically typed, I can't just do this and go ahead because the Rust analyzer is going to shout at me, so I need to add a type to that. So we're going to say, okay, what we're going to take in this case is a reference to a string vector. So a collection consisting of string, and then we're going to return a bunch of stuff. So yeah, so first thing is, okay, when you supply arguments, or when you run your Rust program, right, you're given a bunch of arguments. You're given, I'll just show it to you rather than talk about it. So, but basically, the first argument inside of your argument vector is a path to the Rust binary. So what we need is a query, which we'll assume is the second item, and the path, which is like the third item, right? So we want to do like some manual error checking. So say if argument is less than 3, we want to like throw an error because you haven't supplied the argument. So I'm just going to say, since this is a vector, it has like a length property, and I can just say if args.len, use the length method. If it's less than 2, I'm going to return an error. So I'm going to say, oh, this is an error, not enough argument. And then I think okay, so just say return error, not enough argument. Yeah, so it's an error, it does that. And so if there's no error, we want to just grab our envs, and then we're going to grab the query, which is going to be a reference to args. A reference to args, it gets item 1, and then file path which is going to be a reference to args, and we'll grab like item 2. Interesting thing about Rust, by the way, I really love Rust syntax. You can just say, okay, we've grabbed these 2 items. We want to return a config instance. So this is going to be, config. We're going to have query, and then file path. Exciting. So yeah, I think, yeah. So but then we're missing a bunch of stuff. Like we're missing the return type. So here we're going to say, a bunch of things are happening in this function, right? So it's already complaining. So yeah, so first of all, if we don't have enough arguments, oh, I think I missed something. Yeah, I forgot to check the length here. Yeah, so if we don't have enough arguments, we return an error. If we do have enough arguments, we create like a config instance. And so Rust is statically typed. We need to tell the compiler that once this function is run, this is the type it's going to return. And so in this case, we're going to use like a generic. If you've used TypeScript before, generics are very familiar. So we use something called a result generic. And in the success case, we say we are going to have a config instance. In the error case, we're going to have a reference to a string or something called a string slice. But then we're missing something here. And then what we need to do is to wrap this in an OK variant. So just going to do that. Yeah, I think we're good. So the next thing is we can come down here and try to read the env val, like the argument from the command line. And so the raw standard library is pretty much packed with everything you need. So say you want to read env, read argument. I need to stop saying env. So you want to read the argument, you use a method from the standard library. And so we're just going to grab that and say std env args. So this double colon is kind of like how you get a nested module in JavaScript. So slash, you get the namespace, right? So so if you like import a package, you say, you use slash to like define the path. So let's say, get the standard library, get env, and then call the args method. And then args, I believe, has a collect method. And yeah, so I think we can just try to get the config. So I say, okay, config, show me my function, build, exciting. And then pass in a reference to args. And then we can say, oh, we want to print this out. Let's see what we have, first of all. So we can say the config is this, and the file path is this. So say, okay, config.file, config. Where's my autocomplete? Something is off. 1 second. So I think I should have autocomplete. Yeah, something is off, but there's going to be a bunch of errors, but I'll just use that to file path. Okay, the first one should be query. The second one is going to be file path. So there's going to be a bunch of errors, right? Because I wasn't getting autocomplete, so it means like something is wrong. But it's another feature of Rust that I really like, in that the compiler will try very much to tell you where you've messed up. So right here, if I run cargo run, yeah, so a bunch of errors. It's all right. So the first thing is we have like a problem with the size. So here it says, oh, the size for values of type string vector cannot be known as compilation time. So basically what he's saying is, we're getting something from our argument that we pass to the terminal, but we don't know what it contains. And the Rust compiler can't figure out what it contains. So the Rust compiler wants me to tell it that, okay, this is what we are collecting into a vector. That's what the collect method does. And so what it means is we need to tell the compiler that we're going to have like a vector of string. So we just need to come to like args, say this is going to be a vector of string, and then I think we can run cargo run again. It shows more errors. Exciting. And then, but we're closer than before. And this is mostly because of the types I've defined. So Rust is very strict about types. And in this instance, it's saying, right here on line 13, I have references to strings. But inside of my struct, what I've said that I want to have are strings. You notice this character in front of it. Rust use that to denote references. I'll talk about references in a bit. So what we need to do is just to make sure we pass a string to the struct, and then we're just going to say query to convert a reference of a string to a string. We call the toString method on top of it, and then we can just do that for we'll just do that for file path as well, and then if we run cargo run, I believe, I think there's an error. Let me see. So it says no field query on type result config of string. That's exciting. This is exciting. So I think the problem now that is happening is I wasn't getting my autocomplete because I'll show you right here, I have the type. It says this config is a result generic, right? And the result generic is not the config instance. So that means I need to unwrap the result generic, get my config out of it, and then I can print out to the standard output. So what I'm going to do is say, there's something else I need to do here, which is unwrap the, the generic, and also handle the error. So I'm going to use a method called unwrap or else, which says we're going to unwrap this result generic, but then we also want to undo the error because error handling is good. And say, okay, we're going to handle the error and probably just print the error using the print macro. And then after that, we just print the error and then exit the process. Call process.exit code of 1. Whenever your terminal sees the exit code of 1, it means something has gone wrong. I'm missing a semicolon here. I'm going to save this. And that's auto-imported for me. So I think now if we run cargo run, yes, we see our error. And then if we run cargo run -- which is to supply with argument, we say query file path. We see that we have our query and our file path. So that's pretty much straightforward. So I think doing this, we've run through a bunch of things that I'm supposed to explain today. Right? I mentioned, excuse me. It's back. I just wait for them. So a bunch of things I want to explain real quick before I move on, because I think everything kind of works, but that's because I have like a high-level understanding of how Rust should work. But I've used a bunch of concepts in a bunch of places. Say here, for instance, you can see the ampersand symbol, and that symbol means a reference. So the thing about Rust, say if you're coming from TypeScript or JavaScript, is the things you have to think about that you don't think about when you use dynamic higher level languages. So if you write Python or you write TypeScript, you're not really thinking about memory because those languages have a garbage collector. Thank you. But then once you go down a level, right, you have to start thinking about memory. You think about the stack, the heap, and how, where things are stored. And so one thing that Rust does, which I just try to explain with code, because talk is cheap, show me the code, this is not a good example. I'm looking for the best way to explain it. So what I'm going to do is just going to copy this, comment this out a bit, and then just show an example of ownership and just things that have to do with memory. So in Rust, we have two types of string. We have a normal string, and we have a string slice. So string slices are stored on the stack. So I think that's first in, last out. So it's like a stack of plates. So you put something on the stack, you pop it off the stack. So a string, so if I say let name is equals to bio, for instance, this is a string slice, a literal string, and it's stored on the stack. But then problems start to arise when I have a string instance. So I say let event is equals to string new, and I call this def first. So this particular string is not, one second, okay, no, this is not the right method. One second. Yeah, so this is from, yeah, so this particular string is not stored on the stack. There's something it has that's stored on the stack, but the contents of the string are stored in the heap, right? Three things are stored on the stack. We have like a pointer, the length, and the capacity. So basically, we create like a string, bind it to the events variable, and this tells the allocator that, look for some space, and then put in these characters, then gets the pointer, which is an address that points to the place in memory, the length, the capacity, and store that on the stack. Now, problems start to happen when, say, I have, let's say, a new event, and I assign this to events. There's not really a problem here, but then if I try to print line, I try to print this event, let's see what's going to happen. 1 second, let me just this out. This is a problem in the macro. Yes, this is the error I wanted. So, like, if you use, say, something like TypeScript, this is a very simple operation, right? You have a variable event, you assigned it, you assign the value to a new variable, and you print out events. Easy. But then in Rust, this doesn't work. So the question is, why doesn't it work? And so it's because of what the Rust compiler tries to do to ensure memory safety. And so there are like three main things you need to know in regards to this with Rust, and is that every value can have just one owner. So event owns the value, especially if the value is stored on the heap. So event is the owner, right? And then if you assign that value to a new variable, you've moved the value, so you've changed the owner. And so if you try to use your previous value, Rust is going to complain because it needs to make sure that the particular part of memory you're accessing is safe. And there's a lot more to talk about that, like the drop keyword and something called like a double free error. but we don't have all the time today to talk about that. But basically, just know that there's an owner, there can only be one owner. If you reassign a value, the owner changes, and the Rust compiler is just going to guide you to say, oh, okay, you've made a move here, you can't really do this, you probably want to do a borrow instead. So if I borrowed this particular value rather than move it, I think it's going to run okay. So def first. So we are able to print the events without any error. So yeah, that's just a very short primer on ownership and borrowing and things like that. So yeah. So yeah, let's get back to our CLI application. So I think the next thing we're going to do now is just read our file, because I think that's the next reasonable thing. So we're going to define a method that gets the query, gets the file path, opens the file, tells us if there's an error with opening and reading the file, and then search for what we want inside of the file. So we're going to have a function called run, and run takes in query, which is a string slice. It takes in the file path, which is also a string slice, and then we're going to just open this file. So say let's contents is, so in this case, we're going to use the file system module from the standard library. So say stdfs open, I think that's stdfs dot, second, content, okay. So we say standard library fs dot read to string. Yes, that's not what I need. Yes, so I'm going to pass in the file path and then put a question mark at the end. So that's going to let us know if there are errors and propagate the error. And then what we're going to do next is we have the content, we're going to run, we're going to have like another function called search that takes in the query and takes in the content of the file. And then at the end of this, we're just going to have an OK variant. So, yeah. Yep. Let's just run cargo check to see if there are any type errors. And yeah, of course, it's a type error. Yeah. So first thing it says is this function should return result or option to accept the question mark. And so this is happening because right here, I don't have the return value type, so I need to type that. Second thing is the function is not found in scope. So yeah, so finally we get to the TDD part of today. It's just one test, one unit test we're gonna have. So Rust is great. I think there are a bunch of JavaScript runtimes that have test runners built into them. I think Node now has one, Bon has, well, Rust is great in that it has like its own test runner. So what we're going to do is we want to write a test before we implement functionality to just verify that our functionality is correct. So we're just going to create a test and say it's a function that searches for a string. The first thing we're going to do is create like a string. Say name is Joshua. And we're going to say let content equals, we're going to have, so this just simulates the lines of a string. Joshua is a strong man. Joshua is a powerful man. And finally, Joshua is a money man. So, so yeah, I think, Yeah, so that should, one second, that should do it. So what we want to do is we want to run an assert statement in this and say we want to assert that once we create a function called search and we run that particular function, we are able to get the lines in the file that matches our query. So all of these 3 lines should match, basically. But then I want to restrict it to just one. I'm just going to put Taufik here and put Darrow here. And then, so I'm just going to say, we're going to assert that when we call search with our query and our contents, this should be references. We want to have a vector that returns Joshua is a strong man. In this particular case, I need to just make sure the types, the cases are the same. Yeah. So yeah, I think after that we can, work towards implementing search. So we say search. Search takes in. Oh, by the way, let's fix these errors. So there was an error here. 1 second. I run cargo check again. Yeah. Yeah, there's a bunch of errors. Yeah. So a quick breather. Are you guys still with me? Does it make sense? Does it look exciting? Yeah, that's the goal. Rust is exciting. So there's an error inside of run because we don't have a return type. So what we are saying here is we want to return a result and something called a box. So basically, what we're saying here is when you're trying to open a file, there are like a number of things that could happen. The file could not be available. The file could be corrupted. The file could be empty. And so we're going to use a dynamic error variance that tells us that an error has occurred and, but we don't really know what type it's going to be. But we just know it's going to be an error, right? And then once we have that, and we save and run cargo check, it's going to complain, oh, import, blah, blah, or just import that from the standard library and we are good to go. So, yeah, just say use std error. Yeah, error. Yep. And I think we are good. So cargo check, and the errors are gone. Amazing, 0 errors. So now the next thing we need to do is to implement search, which is just simple, like a simple find. It's not very complicated, but we're going to have search. But the interesting thing about search is it's going to give us a chance to talk about lifetimes, which are concepts that aren't really in other languages, but Rust has them to ensure memory safety. So inside of search, we're going to have the query, which is a string slice. We're going to have the content of the string, which is also a string slice, and do something. So first thing is, we're going to store all of the matched lines inside of a vector. And we're going to make our vector mutable, because in Rust, things are immutable by default. So it's going to be let result is equals to create a new vector. But in this instance, we are going to create a mutable vector. So just going to reduce the size of this. Yes. Let's, done. Oh boy. Sorry, I think I messed this up. 1 second. Oof. Yeah, messed something up. We need to close this. Return and OK. Config. Yeah, so I have like 10 minutes, so I'll try to wrap up real quick. Just need to do this. String. File path is file path to string. And there's an error somewhere else. I think I'm missing one more curly brace here. Okay, yeah. So for the final piece of what we have to do, guys, are you still with me? Yeah, so for the final piece of what we have to do, we're just going to look through the contents of the file, look for the lines in the file that match the query, and then return that. So we're just going to use like a for loop for line in contents.lines, and say if line dot includes if string size, if line dot contains query JavaScript brain, line dot contains query, we're just going to push inside of this. 10 minutes. Time's up. Yeah, 10 minutes. And then the stuff crashed. Time's only up, like 5 minutes. I'll just finish it. Yeah, so we just have to speed run this. I'm just going to push the line inside. It says we can't mutate an immutable vector. What we're going to do is make this mutable. At the end of it, return results. And time is up. So I have to just speed run this real quick. And sadly, I won't have the time to explain lifetimes. But basically, we need to just have something called a lifetime parameter for this function. And so if you know about scope in JavaScript, it's very similar to scope. Like this area where the variable is available for, like block scope, global scope, things like that. And then it's kind of similar in Rust. And so if you have this kind of operation where you're reading from the file, searching from a query, you have to let the compiler know that the string is going to live for this particular amount of time. I would have explained it better if I had more time, but it's basically what we have to do. So in this instance, I'm just going to not use lifetime first of all. And 1 second. We're just going to have a reference to string. We're going to run cargo run query file path. So okay, we have a problem. We don't have a return type, so we need to come here, return a vector that has a reference to a string array. Save that, run cargo run. It tells us, yeah, you probably should add a lifetime. So we're going to do that real quick, which is, just going to modify this and say, oh, here, we're going to have a lifetime param here as well. Here as well, and I think also here. So what we're saying is we want this vector that contains string should live for the shortest amount of time of either of these parameters. There's an explanation that's better than that, and I would refer you to the Rust book for that because I don't have a lot of time. But with this, if we run cargo check, we should be in the clear. So in this case, we need to use the run function. So inside of our main function, oh, before we run it, we can just run our test to see that, okay, does this actually work? So cargo test, run our test suite, and then, oh, isn't that great? We see that search does what we want it to do. So given a query, it's able to find the query and then return the matching path. So what we're going to do is just do some stuff in the terminal real quick. Shit. Sorry about that. Pardon my French. So I want to just create a file real quick. We call it touch, let's touch devfest.txt, and then write some stuff. Welcome to devfest, and then just put that inside of the file. .txt. Interesting. I think I'm missing something. Cat. Oh, sorry, not cat. Echo. Yes. Yeah, so we have a file, and then we're going to say, oh, if we run cargo, we would need to look for devfest inside of devfest.txt. We don't really have an output because we haven't used the function. So I'm just going to spin to run this. I say if let error e, we're going to call run, and a reference to config.query, a reference to config.file path, and say if we have this, there's an error, we're going to just use the print line macro to print the error, and then exit the process. STD. What is this? Is expected something like that? Short on time. So yeah. So final thing is we need to just print out our results. So on line 36, you can get results from here. Look through it. Say for results. For res in results. Print line res. So all things being equal. So let's see what happens. That's a speed run. So there's one final thing I'd like to do it won't take me 2 minutes. Sorry for extending time. I just want to add a color to this so it outlines the particular screen. Because if I run grep, devfest, I don't think this is going to work because there's a flag. Yeah, you see there's a red color, so it's going to show up in a bit. Where is it? Yes, there's a red color. So we want something similar to that. And so we're just going to use a crate real fast. And the crate is called colored. I have it installed already. So we can just go to the top of a file, say, bring all of the method from this crate into this scope. I want all of that. And then after that, we're going to say, what line is it? 26? Yes. So basically, I'm going to say, I want to create a new line which replaces the query with query and makes it blue. But there's like a weird dereference and stuff here. So I'm just going to call this. So 1 second. Back. And then take like a reference to this. And yes, in this instance, this is not going to be a string slice. This is just going to be a string. And then if I run cargo run, errors. Exciting. Final thing here is we expected a vector of string, but found a vectors of string size. I don't think I have enough time, but if I had all the time, would have, do I still have more time? Like, I just want to make that colors. I don't want to eat into the time of the next speaker. But let me see if I can fix this error in 1 minute. So we need to convert this to a string. So I'm just going to call that, save that, cargo run. It's not blue, so there are more errors, but we don't have time. Well, basically, we have a small version of Grep built in Rust, and thank you guys for listening. Yeah. So I don't have time for questions, but
No.
yeah, I'm actually done. I'm done.
Okay.
But Rust is great, and I'll just recommend that if you're very interested in Rust, if all of this looked exciting to you, you can check out the Rust book, which is the gold standard for learning Rust. You have to like read a bunch of stuff, but if you go through this and you spend the time, you can start to call yourself a Rust developer. And yeah, thank you guys once again for listening.